Sine of pi by 3 minus sine inverse of minus 1 by 2 is equal to, since minus pi by 2 comma plus pi by 2 is the principal value branch of sine inverse x. Therefore, sine of minus pi by 6 is equal to minus 1 by 2. So which implies that sine inverse of minus 1 by 2, which is equal to minus pi by 6. So we can write, therefore sine of pi by 3 minus sine inverse of minus 1 by 2, we can write minus pi by 6, which is equal to sine of pi by 3 plus pi by 6. Pi by 3 is 60 degrees and pi by 6 is 30 degrees. 60 plus 30, 90 degrees. That is sine pi by 2. Sine pi by 2 is 1. So we can go with an option D. The value of k, where k is less than 0, for which the function f defined as f of x is equal to 1 minus cos kx upon x sin x, where x not equals to 0, and 1 by 2 where x is equal to 0, is continuous at x is equal to 0. Since f is continuous, if the limit x tends to a, f of x is equal to the functional value f of a. So here limit x tends to 0, f of x is equal to limit x tends to 0, 1 minus cos kx upon x sin x, so which is equal to functional value, that is f of 0. F of 0 is given 1 by 2. So let's find the limit value. Since we know that 1 minus cos theta is equal to 2 sin square theta by 2. So therefore we can write limit x tends to 0. 1 minus cos x we can write 2 sin square kx upon 2 divided by, here let us multiply and divide with x here, x square into sin x upon x. So which is equal to limit x tends to 0, 2 sin kx upon 2 divided by x whole square into 1 upon sin x upon x. And also we know that limit x tends to 0, sin ax upon x is equal to a. So we can use here sin kx upon 2 divided by x is equal to 2 times of k by 2 whole square, and here the denominator 1 upon sin x upon x, as limit x tends to 0, sin x upon x is 1. So which is equal to, it is given 1 by 2. So we have 2 times of k square upon 4 is equal to 1 by 2, or k square is equal to 1. So we have k is equal to plus or minus 1, but since k is less than 0, it is given k less than 0, we can consider the answer k is equal to minus 1. Okay. If A is equal to matrix Aij is a square matrix of order 2 such that Aij is equal to 1 when I not equals to j and 0 when I is equal to j, then A square value is given. It's a second order matrix. Let us consider A is equal to A11, A12, A21, A22, and it is also given for us, it is 1 when I not equals to j and 0 when I is equal to j. So the first element, first row first column element, and second row second column element where I is equal to j, 1 and 1, 2, 2. So we can make 0, and for y not equals to j we can take 1. So this is the matrix A. Now A square is equal to A into A, which is equal to 0, 1, 1, 0, 0, 1, 1, 0. Supplying the row with column multiplication, 0 into 0 plus 1 into 1, and again 0 into 1, 0 plus 1 into 0, 0, 1 into 0, 0 plus 0 into 1, 0, 1 into 1, 1 plus 0 into 0, 0. So you're getting 1 0 0 1 matrix. So A square is 1 0 0 1, which is an identity matrix, and here we can say that option D. Okay. The value of K for which A is equal to K 8 4 2K matrix is a singular matrix. A square matrix is said to be singular. A square matrix is said to be singular if determinant is 0. If its determinant is 0. So determinant of a matrix A, which is equal to K 8 4 2K. So AD minus BC, so K into 2K minus 4 into 8, which is equal to 0. So that is 2K square minus 32 equals to 0, or 2K square is equal to 32, or K square is equal to 16, or K is equal to plus or minus 4. The value of K can be taken plus or minus 4. Option C can be taken. Okay. Find the intervals in which the function f given by f of x is equal to x square minus 4x plus 6 is strictly increasing. We know that a function f is strictly increasing for the values of x for which f dash of x is greater than 0, strictly greater than 0. So let's find the differentiation of the function given f of x is equal to x square minus 4x plus 6, then its derivative f dash of x is equal to 2x minus 4, and now for increasing function f dash x must be greater than 0 for strictly increasing, that is 2x minus 4 is greater than 0, or we can write 2x is greater than 4, or x is greater than 4 by 2, that is 2. So that is x belongs to 2 comma infinity. So we can go with an option B. Okay. Given that A is a square matrix of order 3 and determinant of A is equal to minus 4, then determinant of adjoint of A is equal to. So we know that determinant of adjoint of a matrix is equal to det A whole to the power of n minus 1, where n is the order of a matrix A. Where n is the order of matrix A. So here given order of matrix A is n is equal to 3. So therefore determinant of adjoint of a matrix is equal to det A, and also det A is given minus 4. So we can write minus 4 whole to the power of n minus 1, that is 3 minus 1. So minus 4 whole to the power of 3 minus 1 is 2. So that is 16. Minus 4 whole square is 16, which is fourth option. Okay. A relation R in set A is equal to 1 comma 2 comma 3 is defined as R is equal to 1 comma 1, ordered pairs 1 comma 2, 2 comma 2 and 3 comma 3. Which of the following ordered pair in R shall be removed to make it an equivalence relation? We know that since the smallest equivalence relation in set A is identity relation, is an identity relation, that is IA. So on a given set A is equal to 1 2 3, for a is equal to 1 comma 2 comma 3, the identity relation can be taken as 1 comma 1, 2 comma 2, 3 comma 3. So only 3 elements are here, 3 ordered pairs will have, and the given relation, given r is equal to 1 comma 1, 1 comma 2, 2 comma 2 and 3 comma 3. So here we can observe that there is one additional ordered pair, that is 1 comma 2, so that if we can remove this 1 comma 2, so it becomes an identity relation on A, which is an equivalence relation. So we can say that 1 comma 2 should be removed, that is option B. Okay. If 2A plus B, A minus 2B, 5C minus D, 4C plus 3D matrix is equal to matrix 4 minus 3, 11, 24, then the value of A plus B minus C plus 2D is, we know that two matrices A and B are said to be equal if their orders are same, order of the matrix same, and corresponding elements and their corresponding elements are equal. So here in this given matrices, 2A plus B, A minus 2B, 5C minus D and 4C plus 3D is equal to 4 minus 3, 11, 24. So if you can see the comparing corresponding elements, we can find 2A plus B is equal to 4 and A minus 2B is equal to minus 3 and 5C minus D is equal to corresponding element 11 and 4C plus 3D is equal to 24. Both are 2 by 2 matrices and corresponding elements are compared because they are equal. Now solving the equations. So let us multiply first equation with 2. So let us multiply the equation with 2. So we'll get 4A plus 2B is equal to 8, and second equation A minus 2B is equal to minus 3. So solving these both, by adding these two equations, we'll have 5A is equal to 8 minus 3 is 5. So we'll get A is equal to 1. Substituting A is equal to 1. Substituting A is equal to 1 in the second equation. The second equation here. So 1 minus 2B is equal to minus 3. So which implies 2B is equal to 1 plus 3. So B is equal to 4 upon 2. So we're getting B is equal to 2. So we got A is equal to 1, B is equal to 2, and now solving these two equations, let's multiply the first equation here, 5C minus D is equal to third equation with the 3. So we can write 15C minus 3D is equal to 11 3s are 33, and fourth equation as it is 4C plus 3D is equal to 24. Now adding these two equations, we'll have 19C is equal to 57. So we have 19 times C is equal to 57, or C is equal to 57 upon 19, that is 3. So C values, let us substitute in the first equation. This is third equation. 5 times of C minus D is equal to 11. So which implies 15 minus D is equal to 11, or D is equal to 15 minus 11, that is 4. So we got D is equal to 4, C is equal to 3. So we need to find the value of A plus B minus C plus 2D. So that is 1 plus 2 minus 3 plus 2 into 4. So 1 plus 2 3, 3 minus 3 0, plus 2 times 4 is 8. So first option is the answer. Okay. The point at which the normal to the curve y is equal to x plus 1 upon x, where x is positive greater than 0, is perpendicular to the line 3x minus 4y minus 7 equals to 0. So there is a curve, let us consider y is equal to x plus 1 upon x. Let us consider a point, the tangent is drawn, for which the normal is perpendicular to the tangent at the point P. So this is the normal, and this normal is perpendicular to the line 3x minus 4y minus 7 equals to 0. There is a line 3x minus 4y minus 7 equals to 0 which is perpendicular to normal, which implies that slope of tangent at a point P is slope of the line 3x minus 4y minus 7 equals to 0 because they are parallel. Since normal is perpendicular to parallel line, so the tangent is also perpendicular to the normal. So we can say that the tangent at a point P to the given curve y to the given curve, let me take. So which is, what is slope of the line 3x minus 4y, that is minus a upon b. So minus 3 upon minus 4 which is equal to 3 upon 4. Therefore slope of tangent, let me differentiate. So given y is equal to x plus 1 upon x, slope of tangent is dy by dx at a point P, dy by dx at a point P which is equal to differentiating 1 minus 1 by x square, so which is equal to 3 upon 4. So let us simplify this. So we had 1 minus 3 upon 4 is equal to 1 by x square, or we can add 1 by x square is equal to 4 minus 3 upon 4, 1 upon 4, that is x square is equal to 4. So we may have x is equal to plus or minus 2, but since x is positive given, so we consider x is equal to 2. So substitute x is equal to 2 in the given curve equation. So we'll have y is equal to 2 plus 1 upon 2, that is 2 to the 4 plus 1, 5 by 2. So we can take the value of y is 5 by 2. So the point P can be taken 2 comma 5 by 2. So the first option is the answer. Okay. Sine of tan inverse x where mod x less than 1 is equal to. So let tan inverse x is equal to theta. So which implies tan theta is equal to x. Let's consider a right angle triangle theta. Since tan theta is opposite upon adjacent, say x and adjacent is 1, so hypotenuse will be root over 1 plus x square. So from the diagram we can say sin theta is equal to opposite upon hypotenuse, that is x upon root over 1 plus x square. So sine of tan inverse x is nothing but sine of tan inverse x is equal to, for mod x less than 1, that is the range of x is minus 1 to plus 1. So tan inverse x is theta, so sin theta is equal to x upon root over 1 plus x square, which is fourth option. So you can go with an option 4, right? Let the relation R in the set A is equal to x belongs to integer where 0 less than or equals to x less than or equals to 12 given by R is equal to a comma b such that mod of a minus b is a multiple of 4. Then the equivalence class containing 1 is, so let us first write the ordered pairs. So since x belongs to integer from 0 to 12, so we can take the ordered pairs like 0 comma 0, 0 comma 4 because it's a mod of a minus b is a multiple of 4, and even 4 comma 0 we can consider, 0 comma 8 and even 8 comma 0, next 0 comma 12 or 12 comma 0, next with 1 comma 1, next 1 comma 5 or 5 comma 1 because the difference is divisible by 4, next 1 comma 9, or we can write 9 comma 1, and next with 2 comma 6 or with 6 comma 2, 2 comma 10 or 10 comma 2, and with 3 now 3 comma 3, and then 3 comma 3 plus 4 7, 3 comma 7 we can write, and 7 comma 3 we can write. So these are the possible ordered pairs which satisfies the given condition. So among these many ordered pairs, so we need to find equivalence class containing one. The equivalence class of an element A belongs to A is given by square bracket of A is equal to an element B belongs to the set A such that A comma B belongs to the relation. So we need to find ordered pairs which are related to 1. So we need to consider equivalence class of 1 is 1 comma 5 can be collected, 1 comma 1, 1 comma 5 and 5 comma 1, 1 comma 9 and 9 comma 1. So we can consider the element 1, 5 and 9. So 1, 5 and 9, these are the elements belongs to the set A such that these are formed with an element 1. So 1 comma 5 comma 9 will be the equivalence class containing 1. So option 1 is the answer. Okay. If e power x plus e power y is equal to e power x plus y, then dy by dx is. So e power x plus e power y is equal to e power x plus y, we can write e power x into e power y, or dividing with e power x into e power y. So we have e power x plus e power y upon e power x into e power y is equal to 1, or we can write e power x upon e power x into e power y plus e power y upon e power x into e power y, which is equal to 1. So we can cancel here e power x and e power x, and here e power y and e power y. So we have 1 upon e power y plus 1 upon e power x is equal to 1, or this can also be written e to the power of minus y plus e to the power of minus x is equal to 1. Now differentiating with respect to x, so we have e to the power of minus y is e to the power of minus y into minus dy by dx plus e to the power of minus x differentiation e power minus x into minus 1, which is equal to differentiation of constant 1 is 0. So this can also be written minus e to the power of minus x is equal to e to the power of minus y into dy by dx, or we can write dy by dx is equal to minus e to the power of minus x upon e to the power of minus y. So which can be written as dy by dx is equal to minus e to the power of y into e to the power of minus x, which is equal to minus e to the power of y minus x by using the laws of exponents. So we can give the answer dy by dx is minus e to the power of y minus x. Option C is the answer. Given that matrices A and B are of order 3 by n and m by 5 respectively, then the order of the matrix C is equal to 5 times A plus 3 times B. And since we know that the sum of matrices is possible only when their orders are same. So here C is a matrix which is a sum of scalar multiplication of 5 times of A and scalar multiplication 3 times of matrix B. So if A is of order, if A is a matrix of order 3 by n, then which implies that 5 times of A is also order will be 3 by n, and the order of B is given m by 5, then 3 times the matrix B order is also m by 5. The sum of these two matrices, which is given as C is equal to 5A plus 3B. The addition, the sum is possible. The sum is possible only when the orders are same. That is, order of 5A must be equal to order of 3B. That is, 3 by n must be equal to m by 5. So that we can consider respectively, we can take m is equal to 3 and n is equal to 5. And hence we can say the order of matrix C can be taken as 3 by 5. Order of matrix C must be 3 by 5, then only the sum is possible. So we can go with an option 3 by 5 and m is equal to n, and option B 3 by 5. So here m, it's not necessary, m and n both are not equal, so we can go with an option B only, right? If y is equal to 5 cos x minus 3 sin x, then d square y by dx square, second order derivative we need to find. So let's differentiate with respect to x. So we'll have dy by dx is equal to, differentiation of cos is minus sin, so we can write minus 5 sin x, and differentiation of sin is cos, so minus 3 cos x, and again differentiating with respect to x. So we'll have d by dx or dy by dx, which is equal to, differentiation of sin is cos, so minus 5 cos x, and differentiation of cos is minus sin x, so minus 3 of minus sin x. So that is d square y by dx square, which is equal to minus 5 cos x plus 3 sin x. Or this can also be written by taking minus common, 5 cos x minus 3 sin x. So from the equation 1, that is y is equal to 5 cos x minus 3 sin x, so we can write this is minus y. Therefore d square y by dx square, second order derivative of the function y, which is equal to minus y. So we can go with an option A. Okay. For matrix A is equal to 2, 5, minus 11 and 7, adjoint of a transpose, means transpose of adjoint of a matrix is equal to, for a matrix 2 by 2 matrix, say A is equal to A, B, C, D. So we have adjoint of matrix A is equal to, so we can just interchange these elements where I is equal to J, A and D. So we can interchange these elements, and here this column, like not column, this cross, we have to change the sign for adjoint in 2 by 2 case. So here just change the sign, so we can write minus B and minus C. So adjoint of 2 by 2 matrix is D minus B minus C A, and hence for the given matrix A is equal to 2, 5, minus 11 and 7. So adjoint of a matrix can be written as, so here interchanging 2 and 7, so we can write 7 and 2, and here change the sign, so we can write minus 5 and minus of minus 11, that is plus 11. So this is the adjoint of A, and now transpose of the adjoint of A. Transpose of adjoint is interchanging the rows to columns and columns to rows. So the first row will become first column and second row will become second column. So 7, 11, minus 5, 2. So which is our option C. Option C is the answer, right? The points on the curve x square upon 9 plus y square upon 16, which is equal to 1, which is an ellipse, at which the tangents are parallel to the y-axis. Since we know that the tangents which are drawn parallel to x-axis, because of the slope of x-axis is 0 and slope of any line parallel to x-axis is 0, so we can consider slope of tangent is dy by dx is equal to 0. Suppose here is an ellipse, so dy by dx is equal to 0 when it is parallel to x-axis, and when it is parallel to y-axis, we should consider dx by dy is equal to 0, because dy by dx is not defined. Slope of any line parallel to y-axis is not defined, so we consider that dx by dy is equals to 0. So now let's differentiate this function with respect to y. Differentiate with respect to y, so we'll have differentiation of, that is d by dy of x square upon 9 plus y square upon 16, which is equal to dy of 1. So differentiation of x square upon 9 will be 1 upon 9 into 2x into dx by dy plus differentiation of y square upon 16, that is 1 upon 16, that is 2y, which is equal to differentiation of constant is 0. Since we know that dx by dy is equal to 0 for tangents parallel to y-axis, so take dx by dy is equal to 0, so the first term will become 0 and remaining only 1 by 16 into 2y is equal to 0, so which implies y is equal to 0. So substitute y is equal to 0 in the given equation 1, put y is equal to 0 in 1, so we'll have x square upon 9 plus 0 is equal to 1, or we can write x square is equal to 9, so x is equal to plus or minus 3. So for y is equal to 0, you're getting x is equal to plus or minus 3, so we can consider the point plus or minus 3 comma 0. So option C is the answer. So the points on the curve can be taken plus or minus 3 comma 0. Okay. Given that A is equal to matrix Aij is a square matrix of order 3 by 3 and that A is equal to determinant of A is equal to minus 7, then the value of summation I is equal to 1 to 3 ai2 and capital ai2, where capital Aij denotes the cofactor of the element Aij. So expanding the summation, we can write as for I is equal to 1, so we can write a12 capital A12 plus for I is equal to 2 a22 capital A22 plus for I is equal to 3, so we can write a32 capital A32. So it's nothing but, suppose if I consider the matrix a 3 by 3 matrix, a11 a12 a13 a21 a22 and a23 a31 a32 and a33, this is the matrix. Then we have a12 into cofactor of a12, so here is an element multiplying a12 with respect to its cofactor, then again some a22 into cofactor of a22 and again a32 into cofactor of a32. It's nothing but the second column respectively cofactors you're taking and you're finding the sum. Since we know that sum of product of elements of a row or column with corresponding cofactors is nothing but determinant of the matrix is equal to determinant of matrix A. So here also the same thing, sum of product of elements of a row, elements of second column we are doing with respect to its corresponding cofactors, that is a12 into a12, a22 into a22, a32 into a32. Therefore we can say the summation I is equal to 1 to 3 ai2 a capital ai2, which is nothing but determinant of A, and determinant of A is given minus 7, so we can go with an answer option B minus 7. Okay. If y is equal to log of cos e power x, then dy by dx is equal to, so differentiate with respect to x, so dy by dx is equal to by using chain rule. So first function differentiation of log, that is log is 1 upon cos of e power x, and again differentiation of d by dx of cos of e power x, which is equal to 1 upon cos e power x into differentiation of cos of e power x, again using the chain rule, cos function is minus sine of e power x into again differentiation of e power x, so which is equal to sine e power x upon cos e power x is tan minus tan e power x into differentiation of e power x is e power x. So therefore we can write dy by dx is equal to minus e power x into tan e power x. So which is our option D. So option D is the answer. Based on the given shaded region as the feasible region in the graph, at which point or points is the objective function z is equal to 3x plus 9y is maximum. So here the graph is given and the blue color shaded region is a feasible region, and we know that the optimal value, that's a minimum or maximum, will be obtained for the bounded region at the corner point of feasible region, means vertices of feasible regions. So let me write the vertex, and the objective function is given z is equal to 3x plus 9y. Let us calculate at each vertex. First A 0, 10 and B 5, 5 and C 15, 15 and the point D 0, 20. Set vertex A 0, 10. So the maximum objective function z is equal to 3 into 0 plus 9 into 10, it's 90. And at B the objective function z is equal to 3 into 5 plus 9 into 5, 15 plus 45, it's a 60. And then 15, 15, so z is equal to 3 times of 15 plus 9 times of 15, it's a 45 plus 90 plus 40, 135, 135 plus 45 is 180. And at 0, 20, z is equal to 3 times of 0 plus 9 times of 20, so which is equal to 180. So you can observe that at C and D, so you are getting 180 and 180, that's a maximum value. And also we can observe that the line segment joining the CD, so here you can see, here is a line joining line segment, the joining CD, you take any point, so even if at the point 60, 0 on the line segment, 60, 0 if I substitute 3 into 60 plus 9 into 0, we are getting 180, means same value you are getting, means on the line segment you are getting the same maximum value, you are getting 180. So we can go with an option, every point on the line segment CD will be the answer. Okay, the least value of the function f of x is equal to 2 cos x plus x. Clearly this function is f is continuous on closed interval 0, pi by 2, and f is differentiable on open interval 0 to pi by 2. And the least value or the greatest value can be obtained at the points where f dash of x is equal to 0 or f is not differentiable, and then at the end points. At the end points of the interval. So the least value or the greatest value can be obtained at the points where f dash of x is equal to 0 or f is not differentiable, and at the end points of the interval. So let us differentiate the function. So f dash of x is equal to, differentiation of cos is minus n, so minus 2 sin x, and differentiation of x is 1. So for f dash of x is equal to 0, so which implies 1 minus 2 sin x is equal to 0, implies sin x is equal to 1 by 2. So for sin x is equal to 1 by 2, in the interval 0 to pi by 2 we can take sin x is equal to sin 30 degrees, that is pi by 6. So which implies x is equal to pi by 6. So x is equal to pi by 6 is 1 point, and since this function is differentiable everywhere in 0 to pi by 2, so we can just consider only f dash of x is equal to 0, and at the endpoints of the interval, the endpoints of the interval means we can substitute take x is equal to endpoints, x is equal to 0 and x is equal to pi by 2. Now let us substitute these three values in the given function. So f of 0 is equal to 2 cos 0 plus 0, cos 0 is 1, 2 into 1 2, and then f of pi by 6 is equal to 2 into cos pi by 6 plus pi by 6, cos 30 degrees is root 3 by 2, so we'll have root 3 plus pi by 6, and at x is equal to pi by 2, so f of pi by 2 is equal to 2 cos pi by 2 plus pi by 2, cos pi by 2 is 0, so it is pi by 2 will be getting, and we can find that among these three values, f of 0 and f of pi by 6 and f of pi by 2, the least value can be taken pi by 2. So pi by 2 is the least value among all the three, so we can say that the least value of the function is pi by 2. Option C is the answer. Please like, share, subscribe and support us. Thank you.